The Boeing 787 Dreamliner is a marvel of modern engineering, redefining long-haul travel with its lightweight composite body and fuel efficiency. Passengers enjoy greater comfort, large, dimmable windows, and a quieter, more sustainable journey. Its sleek wings and quiet engines became iconic, symbolizing innovation and progress. But even the most advanced aircraft can hide flaws. This is the story of the Dreamliner's promise and its hidden challenges. The arrival of the Boeing 787 was a proud moment for KLM, symbolizing innovation and a sustainable future. The Dreamliner quickly became the crown jewel of the fleet, connecting Amsterdam to the world with efficiency and comfort. But soon, a routine inspection would reveal a hidden vulnerability deep within its powerful engines. The world of aviation maintenance is one of meticulous routine. It's a world of checklists, schedules, and careful inspection. During one such routine check on a KLM Boeing 787, technicians discovered something unusual. They were examining the aircraft's powerful General Electric GEnx engines. These engines are technological marvels, each capable of producing enormous thrust. As they inspected the engine's interior with a borescope, a specialized camera, they noticed unexpected wear. The fan blades, critical components at the front of the engine, showed signs of rubbing against the engine casing. This was not normal wear and tear. This finding immediately raised alarms within KLM's technical department. The fan blades are designed to spin freely with a precise minimal gap between their tips and the casing. Any contact, known as a fan blade rub, indicates a serious problem. It could be a sign of distortion in the engine structure, or it could be a problem with the bearings that hold the main shaft. The technicians documented their findings carefully. They knew that such an anomaly could compromise the engine's performance. In the worst-case scenario, it could lead to catastrophic failure. The unseen threat was now visible. The initial report from the maintenance team quickly escalated through the proper channels. It went from the hangar floor in Amsterdam to the headquarters of both KLM and the engine manufacturer, General Electric. This is the standard procedure when a potential safety issue is identified. The aviation industry operates on a principle of shared information. An issue found by one airline could affect every airline flying the same equipment. The discovery on this single KLM engine was no longer just a local problem. It had the potential to be a global issue affecting hundreds of Dreamliners around the world. The immediate question was, what caused this damage? The engine had not experienced any known events, like a bird strike, that would explain the rubbing. It had been operating under normal flight conditions. This made the discovery even more puzzling and concerning. Engineers needed to understand the root cause to determine the risk to the entire fleet. The routine check had uncovered a hidden danger. Now, a full-scale investigation would have to begin. The safety of countless passengers and crew members depended on finding answers, and finding them quickly. When the GEnx engine's fan blade rub was discovered, experts from GE, Boeing, and KLM launched a deep investigation. They ruled out manufacturing and pilot error, focusing on high-altitude flights through powerful weather. The culprit? Ice crystal icing. Tiny crystals undetectable by radar, melting and refreezing inside the engine, causing the casing to contract and the blades to rub. A hidden danger revealed. Ice crystal icing is a hidden threat to modern jet engines, forming at high altitudes in clouds filled with tiny, invisible ice crystals. These crystals can build up deep inside the engine, blocking airflow and causing serious problems. In severe cases, ice can break loose, damaging compressor blades and threatening engine safety. The findings from the investigation were just too serious to be kept quiet. The risk wasn't limited to a single airline or a single aircraft. It affected every Boeing 787 powered by a specific model of the General Electric GEnx engine. The potential for multiple engines to be affected by the same weather conditions raised the specter of a dual-engine power loss. This is honestly one of the most critical emergencies a flight crew can face. The safety of the global aviation system really relies on swift and decisive action when such a widespread vulnerability is discovered. It was time for the regulators to get involved. The U.S. Federal Aviation Administration, or FAA, is the primary air safety regulator for American-made aircraft like the Boeing 787. After reviewing the data from General Electric and Boeing, the FAA took action. They issued an Airworthiness Directive, or AD. An AD is a legally enforceable rule that identifies an unsafe condition in a product and prescribes the actions that must be taken to correct the issue. This particular AD was a matter of urgent public safety. It was sent to all airlines operating the affected Boeing 787 aircraft around the world. The concern was now official and global. The FAA's directive outlined the specific problem of fan blade rubbing caused by ice crystal icing. It mandated new operating procedures for pilots. The directive instructed pilots to avoid flying near thunderstorms where these high-altitude ice crystals were likely to be present. Specifically, it required them to stay at least 50 nautical miles away from any significant weather systems. This was a significant restriction, and it could force aircraft to take longer, less efficient routes. While it was a necessary safety measure, it was only a temporary solution. It treated the symptom, not the cause of the problem. The directive also set a timeline for a permanent fix. It required General Electric to develop a modification for the engine that would eliminate the threat. This put immense pressure on the manufacturer to engineer a solution quickly. The Airworthiness Directive transformed the issue from a technical investigation into a mandatory, fleet-wide action. It highlighted the seriousness of the situation to the public and the entire aviation industry. The clock was now ticking. A hardware or software solution had to be found to protect the Dreamliner's engines and restore full operational flexibility to the fleet. With the FAA's directive in place, GE engineers raced to solve the ice crystal icing problem grounding the 787. The breakthrough? A smart software update for the engine's control system, plus minor hardware tweaks. After months of testing, the FAA approved the fix. The Dreamliner could finally soar again, safe from the hidden threat of ice. The hidden fault in the KLM Dreamliner reminds us, aviation safety is a continuous journey, not a destination. Every challenge, like the GEnx engine's ice crystal issue, leads to new knowledge and safer skies. It's this collective effort that makes air travel the safest way to fly, renewed with every takeoff and landing.